I'm Bill Hubscher.
And I'm Lori Meggs, and welcome to a special edition of Focus on Marshall. Bill and I are going to look back at 5 years and 50 episodes.
It's hard to believe we've been at this for 5 years now.
Hard to believe, and it's gone by so fast. So many things have happened here at the Marshall Center. Lots of changes, too.
Oh, you're right about that. So we thought that we'd go ahead and take some time to show you, our viewers, some of our favorite segments, as well as a few surprises along the way.
That's right, but it was hard to choose, Bill, because there were so many successful launches and missions and projects.
And we had no idea when we started this what a long, strange trip it would be. So let's get started from the very beginning and show you a few highlights.
Let's go back to the spring of 2006 in our very first episode. I'm Lori Meggs.
And I'm Bill Hubscher. Welcome to Focus on Marshall.
Our mission is to give you a glimpse into the many labs and test facilities that make up the Marshall Space Flight Center.
At Marshall, we have the expertise and capabilities to make it all happen, from labs to groundwork to flight. Today, we're at the East Test Area, where they have a variety of test stands and test cells, primarily used for propulsion research and verification. Hi, I'm Bill Hubscher.
And I'm Lori Meggs. Today on Focus on Marshall, we'll find out how floating on one of these little things can help us learn more about rendezvous and docking in space.
Well, Lori, I, for one, am really looking forward to seeing what the PRDL comes up with.
Oh yeah, and it was really neat to see how they can test these parts without actually breaking them.
Non-destructive, Lori. Non-destructive.
Sorry.
All right, you guys packed up, ready to go down to Kennedy?
What are you talking about? The launch was last week. We're just getting back. Where were you?
I had to get a haircut.
Did they have a hat that came in your size?
Well, yeah, it's just hard to get one that fit over all that hair.
Right.
Boy, that makes me feel old. Watching my hair literally change color over the course of that 3 minutes there. Did you find any that were some of your favorites? Some of your?
Well, I did, but first I've dug up some behind-the-scenes gems that I think you'll enjoy.
That's gonna hurt, isn't it?
Maybe just a little, but it should be fun.
I can't watch.
Well, just watch with one eye open.
Avert my eyes.
Oh, and speaking of hairstyles.
Ready? Is everyone ready? Yeah. Okay.
They're preparing for a 1/10 scale solid rocket motor firing right now. So let's go check it out.
Oh, well, need to get the gate up.
Oh.
Okay, mine doesn't work.
Let me see. Oh,
And
me neither.
yours doesn't work.
Hello?
This guy can let us in, but I'll call security just in case. Carla, what about the teacher who's... Shut up, you people. Do you need
Line.
need a teleprompter? Cue cards.
Motorhead.
What's your price for flight?
But before Lori gets suited up, we're going to show you how the latest in visual technology... Rats.
Video as well. NASA highlights and everything. And you get,
Shut up back there. Hello.
Yeah, it looked interesting. That was dumb. It looked interesting. Yeah.
I'm really brain dead today.
Hey, Bill, look at all this cool. I'm Lori Meggs.
And I'm Bill Sorry.
Lori, welcome. That's stupid.
And you actually reside at the Jet Propulsion Laboratory. It wouldn't come out of my mouth. Hello.
That X-ray let's go again. Take 4.
All right, it's my turn to mess up now.
Thankfully, we'll never get that close, and even if we did, then it would just be a black hole, right?
That's right. Take it!
Now you'll see how professionals do it.
Where? We have some? There's some
We're gonna
professionals
bring
here?
bring some in.
Lori Chip tells us this with them. Take 12. I don't usually do the closes.
No, you don't.
I usually bring the funny.
Okay.
You missed good bloopers.
Bill, it's amazing the way they can make those intricate things. Your eyes. Sorry, he looked at me and he went.
Okay, now. You know what I'm coming at you with? Say, well.
Hey, y'all can't sell these to bloopers or anything, okay?
They'll be on YouTube later today.
Great, okay.
So I am going to find what I can find.
And I think we can expect a few of them to be walking the halls at Marshall maybe someday.
We hope so. I thought you were going to finish.
You always finish.
Sorry. Watch the magic happen.
Professor at Macon University, Mercer, dadgummit.
Take 3.
I'm Bill Hubscher.
And I'm Lori Meggs. I don't know, what's my name? Sorry.
Thanks a lot for joining us. What? That's what you said to say.
I know, but I couldn't think of what I wanted to say. Okay, go.
I'm Bill Hubscher.
And I'm Lori Meggs, and welcome to a very special edition of
Very special edition of A Focus on Homage. See where we turn up next as we focus. That was horrible.
It's called Focus on Marshall, Bill.
Thanks.
We've only done 45 episodes.
My brain's fried. Okay, well, that wasn't too bad.
I told you it wouldn't hurt.
We've had some fun.
Yes.
But now I'm ready to show some of my favorites.
All right. I can't wait to see them. Why don't you introduce them?
I want to start with one that I thought was one of the most fascinating things I've ever seen, and that was a lab here on Post that will actually print three-dimensional objects. We're at building 4707 in the Rapid Prototyping Lab, and we're joined by one of the engineers here, Curtis Manning. Curtis, thanks for being here with us today. First of all, tell us a little bit more about what rapid prototyping is.
Well, rapid prototyping is a term used to describe the layer upon layer deposition of material to produce three-dimensional parts.
And you can make three-dimensional objects like this.
It's liquid, so it sits in a vat, but as the light hits it, it cures it layer upon layer and cures one layer to the other. And when we're done, we actually grow this part down in the liquid. The powders are actually sprayed into a focal point, and the laser meets that at that focal point and actually welds on the spot.
And the future of prototyping right here at Marshall.
That's it.
Thanks a lot for having us today, Curtis.
Thanks for visiting.
Today on Focus on Marshall, we'll find out how floating on one of these little things can help us learn more about rendezvous and docking in space.
Lori, we're joined by Swati Mohan. She's one of the graduate students at MIT.
So the project we're working with here at Flat Floor is called Swarm, the objective of which is to be able to demonstrate autonomous assembly.
So eventually the sphere might be able to actually put things together in orbit.
That's what we're trying to demonstrate. If we can demonstrate on a small scale, then just sending the algorithms, you can import them to a larger scale and actually put together a telescope in space.
Well, we look forward to seeing your project on orbit.
Great, thank you very much.
On today's program, we're going to take you to a Marshall lab that is helping examine the archaeology and agriculture of Central America. Tell us a little bit about your Mayan project.
Well, this area of Guatemala was the center of the Maya Empire. Around 800 AD, something dramatic happened, and we don't know what. There have been over 100 explanations, but we do know that the Maya disappeared from this region.
And from space, you're able to track, though, where some of these lost cities are now.
And what we have found in the satellite imagery, a vegetation signature, which is showing us the location, the position, the diameter, the circumference of all the Maya sites beneath this pristine tropical forest.
That's some amazing research, Tom, and thank you so much for showing us here today. I'm Bill Hubscher.
And I'm Lori Meggs, and we're here at the Kennedy Space Center, Florida for a historic moment, the launch of the Ares 1X rocket.
We're joined now by Chris Calfee. He is the Ares 1X first stage manager. And Chris, a lot of what people are going to see during the actual test is what you and your team were responsible for.
That's right. The first stage consists of the 4-segment solid rocket booster heritage hardware from Shuttle. That'll burn through the first 2 minutes of flight. At about 2 minutes and 130,000 feet, we'll separate, and the first stage will re-enter, and we'll go recover that hardware.
We're here in the press area again to talk to Ron Unger. He is the roll control system manager. And Ron, first of all, where is the roll control system on the rocket, and what will it be doing during flight?
The roll control system consists of these 2 modules on either side of the interstage here. It's actually the smallest component on the overall vehicle. And what it does is provide a roll moment immediately after launch, about 6 seconds after launch, and it twists the vehicle 90 degrees to put it into a simulated heads-down position for the crew, which also emulates the Ares 1 attitude for launch then.
We look forward to seeing it all come together for a successful flight. Thanks a lot, Ron.
We're on board the Liberty Star going across the Gulf of Mexico. Tell us about the typical trip.
2 smaller tugboats will pick up the barge Pegasus and transport the barge to Michoud, Louisiana. And Michoud, Louisiana is where the external tanks are manufactured. As we go along from there, we'll connect up the tow from the 2 small tugboats and depart Gulfport, Mississippi on what is normally a 4-day trip through the Gulf of Mexico and the Straits of Florida back to Cape Canaveral.
That was great, Bill, and those were some of my favorites, too.
Oh, so hard to narrow it down, too.
Oh, yeah, but I've cobbled a few of my favorites together, starting with getting to interview an Apollo astronaut.
Okay.
I'm here with Dr. Harrison Schmitt, and he is the last person to step foot on the moon. Tell me your impressions of the work being done here at Marshall. The soil that you brought back so many decades ago, being tested here at Marshall, the work being done. Tell me your impressions of that.
Well, it's very important that we fully understand and characterize dust not only on the moon but in space in general. It's an extraordinarily important component of our, shall we say, space environment that we're going to be trying to live in. And even though I'm one of the people that don't think that it's going to be a major problem, it still is something we need to understand.
I'm here with Bob Bagdigian, and he is the project manager for the Regenerative Environmental Control and Life Support System here at the Marshall Center.
A regenerative environmental control and life support system, or ECLS for short, is that portion of the system that provides them oxygen and water and does it in a way that minimizes the amount of oxygen and water that have to be resupplied from the ground.
We use only the finest ingredients: urine, perspiration, food vapors, bath water, simulated animal waste, and a touch of iodine. All right, well, you tell me I have to take the test, so I'm taking your word for it. Tastes like water. Thanks, Lane. And Tim, I'm told that you're charged with getting this rocket train ready to roll. Why do we use a train to ship these segments?
Well, it's actually the most effective and efficient way to transport something of this size and weight across the country. Interfaces a lot less with other traffic, and with this particular size, it's very effective to get them.
And joining me now is Don Beckmeyer. He is the test project manager here at Stennis. And Don, I know this is something you guys didn't just start doing yesterday.
That's correct. We've been testing Space Shuttle main engines here for 33 years now. Well, you're going to see a lot of billowing smoke. It's actually steam from the cooling water. And you will hear a lot of rumbling, and you'll actually be able to feel it.
I'm here at Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida.
As we speak, NASA is developing the next generation of spacecraft and launch vehicles that will take us to the moon. And these missions are the precursor missions that will go out and reconnaissance and scout out the places where we want to land. So we're really excited to be at this point. It's been a tough road to get here. Integrating two missions on one launch vehicle is a tough thing to do.
Todd, what is it like to see, first of all this work of the Marshall team sitting here on the launch pad ready to go?
It is wonderful to see this. There's times through this whole process where you just don't know how it's going to come together. The mapping mission for LRO was approved. They had some mass growth, so they had to go to a larger booster, and suddenly we had excess capacity, and they put out a call for how to use that extra 1,000 kilograms, and L-Cross was the result.
Tell us about what happens here in the engine shop.
Once an engine, or all three engines, return from their previous mission, they go through a horizontal and vertical processing that takes about 8 to 10 weeks. Since STS-1, we have flown 46 different engines. However, we've constantly upgraded them.
And why do we need these upgrades?
Well, primarily for safety and reliability.
And we're talking specifically about main engines for us. Tell us what happens to the main engines in this facility.
It's in this facility that they both install the main engines and remove them after it lands after the orbiter lands at Kennedy Space Center.
Well, Bill, it's been an exciting ride, and I'm glad we could share some of our memories and some of the lighter moments too.
It has been a lot of fun. And we look forward to sharing with you a lot of the work being done out here at the Marshall Space Flight Center in the future as well.
We hope you've enjoyed the show as much as we have. Join us next time as we focus on Marshall.